Hello and welcome to my YouTube channel Physics for All. I'm Dr. Abbas, and in our next lecture we are going to discuss third method, which is known as integration factor. So in this lecture we will just discuss about the standard form. When you will be given any problem, the first step you have to do is you will convert the given problem into its standard form. This is the equation one is standard form, where you should keep in mind that with the highest derivative, that in this case is first order derivative, here we have product of 1 multiplied by 1, x and 1, there is nothing multiplied or divided. And in the second part, anything that is given multiply, divide, addition, subtraction with y is known as p of x. You will consider it as p of x, and what you will have in terms of x on the other side will be considered as q of x. So in this way you will transform your given problem into standard form, where the highest order will be multiplied by 1, anything with this y will be considered as p of x, and rest the things independent of y, for example, will be considered as q of x. Once you have this standard form of given equation, given problem, then you will define your integration factor I of x, which is defined as exponential integral of p of x d of x. Here this p of x is the same p of x you will obtain from this equation, from this point. So you can see that this integration factor depends only on x and is independent of y. So once you will calculate this integration factor I of x by applying this formula, you will multiply this I of x to this standard equation number 1. Okay, when you will multiply it, you will obtain something like that: I of x y prime plus p of x I of x times y is equal to I of x multiplied by q of x. So once you will achieve this form, then you will see that your given problem will be much more simplified and it will be easier for you to calculate its answer. So let's start our first example, where we are asked to apply this integration factor method on given problem, that is y prime minus 2xy is equal to x. Okay, let's start its solution by defining the value of p of x and q of x. As I said before, to define p of x and q of x, you should be very careful. You see the highest order derivative, that is y prime here, and if it's multiplied by 1, okay, if it has some other terms, you should first convert it into standard form. So it's already in standard form, so we can choose our p of x and q of x. So here p of x will be minus 2x. The whole term multiplied or added or subtracted from this one. And q of x will be this simply x. Now we have defined p of x and q of x. So the next step is we will define our integration factor I of x. By formula we have I of x is equal to exponential power integral of p of x d of x. So p of x here is minus 2x, and you will replace this p of x with minus 2x. So when you will solve this integral, you will find the answer exponential power minus x squared. How I obtained this? I just simply integrated this integral minus 2x dx. So I will take this minus 2 outside. The rest we have x. Here we will use power formula that will give us x power 1 plus 1 we had a dot by 2. So this 2 will be cancelled with this 2, and we will obtain this minus x squared. So this whole integral on exponential will be replaced by this minus x squared here. Now we have obtained this I of x. So we will multiply this exponential power minus x squared with this equation y prime minus 2xy is equal to x. Once you do so, now here you have to analyze carefully this equation. This side of the equation, if you see, you will find here that first we had this term exponential power minus x squared times the derivative of y minus, we have this y as it is, and here this term suggests that it is the derivative of exponential power minus x square, which is minus 2x into exponential power minus x square. If you take the derivative of this exponential power minus x square, you will obtain exponential minus x square times derivative of minus x square. And if you take the derivative of this derivative of this minus x square with respect to x, you will obtain this minus 2x. Okay, friends, so far we have simplified this equation. Now here I'm going to invert the product rule. So I can I can write both these terms in the form of product rule as a single derivative d by dx of exponential minus x squared times y. On the other side, I keep the same equation, same value. Okay, now I will integrate both sides. When I will integrate, this derivative will be cancelled. So my objective is to find this y. And on the other side, here I will have this integral of exponential x case time x dx. Okay. So further, when what I want to calculate this y. So to obtain this y, I will divide both sides with exponential minus x square. So here it will be cancelled, and on this side it will be multiplied by exponential x square, and this term with c also will be multiplied with exponential x square. So times this c. So now this is our required form, but still we have this integral of exponential minus x square times x dx. If you solve it, you will simply find its answer that it will be equal to minus 1 by 2. So you will obtain the solution in this form. If you had given the initial conditions, you would be able to calculate this c the constant of integration as well. So how is, you can stop the video right here, and you can try by yourself if you can solve this integral and find this solution. Okay, if you calculated it, it's nice, but if you can't, I'm going to help you. So we had this integral of exponential power minus x squared times x dx. So I'm calling it I, and here I'm going to just substitute another variable u with minus x square. So if I take the derivative on both sides, du will be equal to minus 2x dx. So if I want to replace this x with u, here what I need minus 2x. But at the moment in this relation, I have just x. So what I can do, I will multiply and divide it with minus 2 in this way. So now I can see minus 2x dx, which can be replaced with du, and this minus x square with u. And this minus 1 by 2 is a constant, so I will take it out here. So what we have minus 1 by 2, and when you will integrate this exponential you will simplify exponential power u plus constant of integration. Okay, so in the next step we will put back this u is equal to minus x square. So here we have minus 1 by 2 times exponential power minus x square plus constant of integration. Okay, so now we will confirm that we obtained this value. So when you put this value of integral back here in this equation, what you obtained, y times exponential power minus x square is equal to minus 1 by 2 times exponential minus x square plus c. So in the next step, what I want to calculate is y. So to obtain this y, here we had exponential power minus x square. I will take it on other side, so it will be multiplied with both terms. And further, if I want to simplify it, this is exponential power x square. Here we have exponential power minus x square. Both of them are being multiplied, so powers will be added and they will cancel each other, and exponential power 0 will give you 1. 1 times this minus 1 by 2, and this term will remain same. So in the next step, you can see that here we have minus 1 by 2 times c times exponential x square. Okay, if we just rearrange them, so our final answer is y is equal to c times exponential power x square minus 1 by 2. And that's our required solution. Okay, so we move to another example. We are given y prime minus 5y is equal to 0, and we are asked to solve this problem by using the method of integration factor. So for this, the first step is you have to see either this given equation is in its standard form or not. If not, you will convert it. For that purpose, I told you that with the higher power derivative, there should be multiplied by 1. So currently it's in its standard form, so you don't need to do anything further. So you can find your px and q of x. Here p of x is minus 5 and q of x is 0. So now we have p of x and q of x. Using them, we will find our integration factor, that is defined as I of x is equal to exponential power integral p of x dx. So here p of x is equal to minus 5. So what you do in first step, you will find the integral of this integral, and then you put back it here. So minus 5 is constant, you take it out, and here you have just 1, and integral of 1 is x. So you will find exponential power minus 5x. So now you have this integration factor I of x, that is equal to exponential power minus 5x. So multiply with this equation. When you will multiply on both sides, you will have exponential power minus 5x times y prime minus 5 into exponential power minus 5x. This is our integration factor times y is equal to 0. Okay. Now again, if you focus on this equation, you will find that here we have applied the product rule. Okay, for example, here we have the first term as it is, derivative of second plus the second term as it is, and derivative of first, that will give us this minus 5. So we can combine them in the form of simple derivative. Further, we can integrate it, and we can cancel that derivative, and we can move toward our solution. So you will obtain this dy over dx into y times exponential power minus 5x is equal to 0. If you integrate it, this derivative will be dropped, and you will simply have y is equal to exponential power minus 5x is equal to some constant of integration. Okay, so if you want to find this y, you just take it on other side this exponential, and your y is equal to c times exponential power 5x. So that's all what we had from this lecture, and see you in the next lecture with some applications of ordinary differential equations. If you have any comments, please do comment in the comment section. Thank you very much.